Hello guys, so Medix Tutor here. Today we'll be looking at simplifying algebraic expressions involving exponents. So to simplify algebraic expressions using exponents, there are actually a few rules that you should know about exponents. So these rules include multiplication, division, power of a power of a quotient, negative exponent, zero exponent, fraction with negative exponent. So here, I'll be writing them here. So multiplication rule. So the multiplication rule just states that if you're multiplying am into an, make sure that for the multiplication rule the bases are always the same. When you're multiplying am with an, this will always equal to am plus n. For example, let's say you're multiplying 5 squared into 5 cubed, right? You would apply this here and you would get 5, 3 plus 2. So you might wonder why this is the case if you were like me, right? So the reason behind this is due to the fact that when you write this down, you actually get 5 fives. For example, you do 5 into 5, right? And that's 2 fives, right? And then into 5, 5, 5, right? So when you write this out, actually it becomes 5 into 5, 5 into 5 into 5. So when you count this out, 1, 2, 3, 4, and 5. So this makes 5 fives. Next rule for us is division. So for division, the rule applies that you subtract them. Like over here you add them, but in division you do the opposite, which is subtraction. So let's say you have am over an. Make sure the bases are same always. So this becomes am minus n. So why this is the case, you might wonder. So let's say we have 5 over 5, 3, right? So first we'll apply the rule to this, which becomes 5 minus 3, which is also equal to 5 is a 2. The rule behind this is that when you do 5 into 5 into 5 into 5 into 5, because that's what an exponent is. An exponent is when you just multiply some exponent is when you multiply something when you multiply the base by itself. So the exponent itself actually tells you how many times the base is being multiplied by itself. So over here, since there's a 5, the base is being multiplied by itself 5 times. So 5. So here we multiply the base 5 times, but now we have to divide it. So we can write like this, 5 into 5. And just so you guys know that a fraction is basically division too, which is because this symbol, right? You guys learned this in like a higher class probably. I'm not sure if you guys learned it yet or not, but this symbol right here just means a fraction. This stands for numerator, this stands for denominator. It's just a simplified version of the fraction. A fraction just means you're dividing the numerator by the denominator. Not that hard. So now that you got that done, you're gonna look here if there's anything you can cancel. So you see how we got a 2 here? So we're gonna cancel. So we're gonna we're gonna cancel, right? So we do 1, 2, and 3. So you see how we subtracted these five of fives here. I mean 3 of fives here. So we subtracted 3 fives from 5 itself. So that makes 5 minus 3, just like here. For power of a quotient, right? Power of a quotient. Power of a quotient. What we do is we would multiply the multiply the quotient, like we would multiply the exponent with it. Like here, I'll give you guys an example. So here's am, put a bracket, there's an n here, so this becomes a m n because you're multiplying it, right? So an example of this can be 5 bracket n, and then we'll do m here. Or actually, we're gonna use actual numbers to make this simpler. So 5, 2, and we'll do a 3, which is equal to 5, 3 into 2, which is equal to 5, 6. So how do we get here? So basically for 5 square, right, you know that you're multiplying this 3 times. So you know that you're doing 5 into 5 3 times. So what this just means is 5 to 5, that's 1 time, to 5 into 5, that's another time, right? Into 5 into 5, that's the 3rd time. So when you count the number of 5s here, which is 5, 5, and one more 5, there's gonna be 1 5, 2 5, 3 5, 4 5, 5 5, 6 5. So that's the reasoning behind this. Negative exponent. So we'll get to 0 exponent first, and then we'll do negative exponent. So what is 0 exponent is? Exponent. So there's a law for the 0 exponent that anything raised to 0 is always 1. So x0 equal 1. So anything raised to 0 always 1. You guys want to make note of that anything raised to 0 is always 1, no matter what the number is. So here we can see that this raised to 0 is a 1 over here. So now you might be wondering what's the logic behind this? So you guys know how when you multiply 5 squared, right? So when you multiply 5 squared over here, what you're basically doing is 5 into 5, right guys? What you're basically doing is 5 into 5. But as the law of subtraction or division states here, when you divide two things, so when you add two things, you're adding their exponents. So what's happening here is 5 1 into 5 1, which is 5 2, right? But when you guys are dividing something over here, you subtract it. So over here, let's say you have a 5 2 over 5 2 itself, right? You would subtract it to get 5 0 over 5 0. I meant you would subtract it to get an answer of 5 0. So to put this in, which is also equals to 1. To put this into perspective, let's say 5 into 5, right? Over 5 into 5. right? So these 5s would actually cancel out with each other to produce a number of 1. Now let's get into the negative exponent. Negative exponent, right? So the law of negative exponents, there's another law for negative exponents. Anything raised to a negative number is the reciprocal. Anything raised a negative number is a reciprocal plus exponent. This is really bad wording here. I don't know how I could word this any better, but I'll be showing you guys what I mean here. So anything raised to a negative number is the reciprocal and the exponent, right? So how we're gonna do this? We're gonna do a negative m right here. So what this just means is 1 over a, you reciprocal it, because of the negative value, you reciprocal it, and you multiply it by 1. So what's happening here? Now you might be wondering, the case here is that, let's say you have a table of values, let's say 2n, right? Let's say 2n. There's a 2n right here. So if you notice, if n goes up, n goes up, n equals 1 here, n equals 2 here, n equals 0 here, n equals negative 1 here, n equals, sorry, I'll remove this from here, I'll put this somewhere else. Do 2n, let's say y equals 2n, right? This is the output, this is the input. So n equals negative 2, right? So what we will be doing is we'll be substituting these values in for n. So y equals 2, sorry, wait, meant n is an exponent here, it's not a, n is an exponent here. This is the input, n is the input. So y is equal to 2 raised to 0, which we learned here, anything raised to 0 is 1. Therefore, y is equal to 1. Here we're going to do y is equal to 2, 1. We know that there's so this is just y is equal to 2. Therefore, over here, y is equal to 2. Now we're going to do y is equals to, n is equals to 2. N is equals to 2. So n is equals to 2. So y is equals to 2 squared, because we're substituting n into the equation. This gives us y is equals to 2 into 2 because of the exponent, which is y equals to 4. So here, this becomes 4. Now, we're going to take the negative exponents. So this is where it becomes a bit tricky. So this is basically a graph. So we're basically making a graph here. N is for the x-axis, y is for the y-axis. But here we're going to look at the pattern of how they're actually like going from 1, how the output is going from 1 to 2, 2 to 4. Here we're going to do n is equals to negative 2. So y equals to 2, negative 2. So here is going to be y equals to over 2 squared, which is going to be 1 over 4. Don't worry about how we're getting to the reciprocal yet. Just know that it's this negative part of the exponent that actually gets us there, right? Don't worry about it yet. We're going to learn about it just in a second. Next n value is negative 1, so we're going to do n equals negative 1. Y equals 2 minus 1. So this becomes y equals 1 over 2. Now that we have these two y values, we're going to put them in here. Y equals 1 over 2. Y equals 1 over 4. Or 4. Ooh, so how would I highlight this? Okay. Okay, so I'm going to bring this right here. Sorry about that. I'm going to bring this right next to it, so you know which input correlates to which output. So these are the outputs. These are the inputs. So you guys might be noticing a pattern that when you do it this way, the output actually, when you multiply it this way, it becomes into 2 as you go down for the input. But when you go up to the negative value, you are actually dividing by 2. You're actually dividing by 2 here. And if y'all remember, in earlier grades, you may have learned this. And if you didn't, well, you're learning it now. So whenever you're dividing a value by any number, you always take its reciprocal, because the denominator, like we stated up here, the denominator is dividing from the numerator. So you would write this as x into 1 over a, which is also x over 1 into 1 over a, and when you multiply this, you get x over a. That should be clear now. So now coming back here, we can see the pattern over here for the outputs. You can see the pattern in the outputs that whenever our x value goes to negative, our y value divides, right? Divides by the base. So that's why this base actually moves down. It moves down. It reciprocals itself whenever the n value is negative. Now let's take an example. Let's take 5, negative 2, right? We're going to write this as 5, 1 over 5 whole squared. Now we're going to solve for it. Negative 2 equals 1 over 25. So over here, since it's a reciprocal, since it's a negative exponent, we reciprocal the numerator, and we applied this exponent to it in the denominator. So this is how you solve these types of questions. Now we're gonna move on to a fraction with a negative exponent. So in here, so we're gonna do fraction with a negative exponent. So let's say we have a over b raised to negative n, right guys? So when we get rid of this negative, we actually reciprocal it, like we said here, reciprocal b over a, and then this becomes n. Now we click equal. Now we enter equal. Now we equate it. So whenever you're actually adding exponents to a fraction, you always add them to the numerator and the denominator. Sorry. So an. So this just becomes bn over an. Alright guys, once I'm repeating myself, whenever you're adding exponents to a fraction, you add the exponent to the numerator and the denominator separately. This negative value just reciprocals these two positions. It brings the denominator up and the numerator down. Reciprocal is just when you swap their places, so 1 over 2 becomes 2 over 1. We're gonna try solving a question for fraction with a negative exponent. So we'll do a question like 2/4. Actually, we'll do a question like 3/5. 3/5 bracket -2. Now we're gonna equate it. So this becomes 5/3, 2, which also becomes 25/9. And if it's factorable even further, you always want to factor it. But I'm not going to look into factoring it, nor am I going to think about it, because this was just an example. But if your equation is always factorable, you always want to factor it. I mean your answer. Also, depending on some teachers might want you guys to put them in mixed numbers. Some teachers might specify that in the question if you need in mixed numbers, improper fraction, radical, or whatever. They will specify it in the question. For this question, we'll just convert it into mixed number. So here, for mixed number, what we do is we just do 9 divided by 9. So we get 2 minus 1, 8. We divide 25 by 9. And this value is the value that the whole number in our mixed fraction. Then we do 25 subtracted by 18, which is 7. And we have our value is 2/7/9 for our mixed fraction. Now that we know all of these rules, I would like to add one more rule here. Actually, this one rule is, let's say that over here, right, there's a negative b, right, over b. Now this is a really common mistake in these types of questions. What some people do is they try solving like this, which is wrong. How you want to solve it is I'll take a better exponent here. I'll do an n, right? How you want to solve these questions is you want to go 1/a raised to n over b. So what this just is 1/a raised to n divided by b, which is equals to 1/a raised to n into 1/b, like we did up here. This is just a reciprocal multiplied. A division, when you're dividing a number by another number, that's just multiplying it by another reciprocal. So we reciprocal the b over here, and we did 1/a raised to n into 1/b. So this is how you would solve questions like these. Become a and b. Next, now we'll be solving some practical questions, right? So you might want to stop the video and do some of these questions by yourself. So, and I'll be giving you guys some time on the video to do these questions. So our first question is a squared 3. So pause the video to solve this question. Alright, now we'll be solving this question. So what this just really means is that you're doing a squared, right, 3 times into a squared into a squared. So this is just a into a into a into a into a into a. So there's 1, 2, 3, 4, 5, 6. But if you remember from the law for here power of a quotient, which makes this much simpler. Over here, what you could do is a squared 3 is also equals to a 2 into 3, which is equals to a raised to 6. This is a much simpler way to do these types of questions. Our next question will be this question. Stop the video to try and solve it. So this is gonna be, let me think about this. X squared. How about 2x squared? You guys can stop the video to think about it and try and solve it. So to solve this question, what we would do here is we would apply this rule that we applied here. We would multiply their quotients. And here, so here whenever there is a coefficient to the variable, right? What you would do is you would add this exponent separately. So there's a 1 here, there's a 1 here. So you would multiply this 2 with this 1 here, this 2 with this 1 here. So this becomes a 2 raised to 2 x raised to 2, which is also x raised to 6, 4x squared. Our next question we can solve is gonna be this. You guys can pause the video and try to solve this question. So to solve this question, you would do the same thing that we applied here. You would do the same thing that we applied in question number 2. So what you would do is you would since these are coefficients of each other, you'd multiply into their exponents separately. So what this would be is it become a mn b 3n, right? And this would become a 2 squared, a squared, and b 2n. Remember that whenever there is an exponent after a bracket, like we learned in this rule, power of a quotient, you always multiply it. That's why we're multiplying the exponents together. Now here we'll apply the law of multiplication for exponents, which is a n into a m is equals to a n plus m. And so we can see that these are getting multiplied with each other. So we want to make sure that we apply this rule to the coefficients with the same base. So here we're going to do amn plus 2, because this one has a exponent of 2. Here we're going to do b 3n plus 2n, right? This eventually becomes a mn plus 2 and this becomes b 5n. Another example we could do is, so sometimes in our textbooks the question might ask you to write an expression with a positive exponent. So how would you do such questions? So let's say question 4 we can have as 2 raised to 8 over 2 raised to minus 5. So first we see that their bases are same. Now we can use the law of division here. Law of division. This becomes 2, and then we do 8 minus, we'll put the minus 5 in brackets because there's a negative sign there already. So this becomes 2, 8 plus 5, which also becomes 2, 13, and that's it. That's where we stop. We do not simplify this question further because the question stated that the question asked you to write it in a single power with a positive exponent. So questions like these can happen sometimes in your tests, sometimes in your textbooks, etc. So just be sure that you know that questions like these exist. Another question we can try is 5. We could do 3. Yep. So to solve such questions like we did here, we would multiply the quotient of an exponent. We would apply this law, which is up here, power of a quotient. You would multiply these together. So we know that these are different coefficients. So you would multiply each separately like we did in the previous examples. So this becomes A 1, 3 and B 1, 3. Now you would multiply these together. This becomes A 3, B 3. One last question we could do is here. Let me think of a difficult question. Let's see. Let me open up a textbook. I'll be using this question from the Nelson textbook, exponential functions. I'll be using question 18 on page number 223. Page 223, Nelson functions 11. Here we can see that so this question states, so it's question 18C. It states b 2m plus 3n is divided by bm minus n. So you could solve this by either putting it into fraction form, or you could just solve it normally because the coefficients here are same and you could apply the law of division. So instead of putting it into fraction form, I prefer to solve it using the law of division because it just makes things simpler and complicates them less. So this becomes b, so this would be b 2m plus 3n minus m minus n. This becomes 2m plus 3n minus m plus n. we close the bracket here. This would become, this would become m plus 4n right there. So such questions can pop up on your test. We could try two more hard questions I found while skipping through the textbook. So the other question is on 18F. It is so 3x raised to 4, 6 minus m, and 1 over x m. You guys can try doing this question by yourself. I'll give you guys a minute. Now we will start solving this question. So we would actually first open this up. We would multiply it in here, which would make it 3 raised to 6 minus m, and x 4 raised to 6 minus m. We would make a square bracket here, and this was 1 raised to m and x raised to m. Then we would leave it, then we would make it 3, 6 minus m here, and x 24 minus 4m, because we're filing this in. Then we would do 1m over xm. Now we know m raised to anything is just 1, so we could remove that 1. Now we'll just multiply these two together. So we know that there's a 1 as denominator here, because any whole number is just divided by 1. So this becomes 3, 6 minus m, x 24 minus 4m over x m. Now we would subtract the same coefficients, and this becomes 3, 6 minus m. This could also be written as x raised to minus m, so we'll use it like that. X 24 is 4m minus m, 3, 6 minus m, x 24 minus 5m. And that's the solution for this question. 3, 6 minus m. We could remove these brackets if you like. I usually prefer them on, but you guys could also remove them because it doesn't really matter. Same thing. For question let's see what other question we could do. in this textbook, we could do this one last question, which is question 12. Question 12. Page 221, question 12. Kendra, Eric, when are studying they wish to evaluate 3 raised to negative 2 into 3. Right? Now, so Kendra here, she notices errors in Eric and Vin's solutions, right? So I'll draw Eric's solution here. So this is Eric's. So he did 3 minus 2 into 3. Right? And this is Vin's. Oops. So, sorry. Can you guys try finding the errors in this question? I'll give you guys some time. Alright, so first we would like to solve this question by ourselves. So 3 raised to negative 2 into 3. So what this basically is, it's 3 raised to negative 2 into 3, 1. Now, from what we know from the law of multiplication, we add the exponents. So this just becomes 3 minus 2 plus 1, which is also minus 1. Now, now from here, what we can do is, since there's a negative sign here, we know that we reciprocal it due to the law of negative exponents. So this becomes 1 over 3 raised to 1, right? Which is also 1 over 3. Now we can compare Vin and Eric's solutions to our answers to see what they did wrong here. So Eric's solution, he did negative 2, and there's an imaginary 1 here. He added them, he got the answer of negative 1. Oops, the mistake is right here. He added a negative sign for no reason. There was really no need for a negative sign. When there's a negative exponent here, you do not add a negative sign in front of the coefficient. That will make your answer wrong. So that's where he went wrong. Let's look at Vin's solution. So Vin's solution actually went wrong in the first part itself. So over here, Vin didn't actually add the 2 exponents, giving him this value, which when reciprocal gave him this value, and he ended up with a 1 over 9. So I hope this video helped you guys and made your basic foundations clear for you guys. Hope you guys have a good day. Make sure to like the video if you enjoyed it. Subscribe for more like this. Peace.